Hi everyone, here is your exam 3 review video. So before we get started, I wanted to point out that there are some old videos. If you go into week 13, you can see there's a link to older videos if you want to go through those. Another great resource is that video I did before week 12 that basically broke down the 4 biggest places that points are going to come from on the exam. Don't forget we have those extra credit knowledge checks. And then if you go to the exam 3 review folder, the key is up now for the exam I passed out in class last semester's exam. There's another sample exam there. You have some review notes, which are really good to go through. They basically describe what's going to be tested, and then they have some example questions. So my suggestion would be to try those review notes before you tackle one of the sample exams, because they can make sure that you have the mastery of the content before you go and actually see, can I do the identification on top of all that. You got some more sample problems, and then this another exam 3 review. So the key to that exam 3 review is here, as well as some answers, but that's what I'm going to be going over today in my video. So if you click on that, it'll open up an exam 3 review. So I already have that open in my other window. So in this exam review, I basically tell you all the things that you need to be able to do. So I give you a checklist of things that you can be like, okay, I know this. I don't have to think about it anymore. So in part 6 and 7, we talked about sampling distributions. We have 3 different options for our sampling distributions. We have our sample proportion stuff, right? A sample proportion is denoted with a p hat. And the only thing we have for that is approximate normal. Now remember, when you're filling in these, because I usually fill in the blanks like the one below, the only 2 pieces that you're going to fill in are the mean and standard deviation. Everything else is notation. This notation here is telling me that if I were to take a sample and find a proportion, where that proportion will come from is this underlying approximate normal distribution. So when we did the rolling of dice, we said, okay, well, when we roll a dice 20 times, we might get out 11 heads, and find out that we're getting 55% heads for our sample. But we know that the majority of the time, or that the most likely thing to happen, is to get 50% heads. So we knew that there was some underlying normal distribution centered at 0.5 where our little tiny 0.55 fell in and was just one value on that. So in most of the classes, we actually put some magnets on the board and made a dot plot. So this is just saying, oh no, that all of the p-hats, all of those little magnets, all those dots for the dot plot or whatever it might be, they come from this underlying normal distribution centered at the real proportion and the real standard deviation. So the only pieces you're filling in again are these 2. We also talked about sample means, which is the second 2. Sample means had 2 different possibilities, either the normal or the approximate normal distribution. All right. Once we identify the distribution, this will always be your part A on the problem, because I'm trying to make sure that we are, I'm leading you towards what you're supposed to be doing. Part B will be to calculate the probability, and you're going to do that doing normal CDF. So this is what you'll see if you look at all the old sample exams, step 1, step 2, part A, part B. Now, what is a possible part C is finding values that result in a given area. This would be using inverse norm. We didn't do this in part 6, but it was in the part 7 stuff. So this is part 7 only. And that's a possible part C. It's not guaranteed. A and B, 100%, those are going to happen. And then as a potential multiple choice, you might have to answer questions about what the sample size changing will do to our distributions, and about the central limit theorem. So just as a review, as your n gets large, right, we're going to see our distributions are going to become more normal. We're going to have the same center, the same mean, and we'll have a smaller standard deviation, because it will be harder and harder to get something unusual if we have a large sample. We're going to see that law of large numbers starting to converge towards what we expect, that 0.5. The central limit theorem, this was that we can start with something that looks crazy as heck, and it will become approximately normal as long as our n is big enough. Now be careful This is for all the x's, all the observations, and our x bars are what's going to be approximately normal. When you take the average, all of this sort of weirdness of the original distribution will go away, and you'll start seeing approximate normality as long as your sample is big enough. Okay, so you've got some example questions. This is exactly how you'll see it on the exam. If we read through here, it says, suppose it is generally accepted that the average is skewed to the left, or the sleep is skewed to the left with a, oh no, oh no, oh no. Sorry. The average amount of sleep a college student gets. So it turns out that this isn't even the average yet. This is what our underlying variable is, the average amount of sleep someone gets. This is our x, and this is quantitative. Because as we noted in class on last week, whenever we're doing stuff in part 6, we're dealing with a quantitative variable. Is skewed to the left, so this is telling us it's non-normal, with a mean of 7.1 and a standard deviation of 1.5. There is nothing in this sentence to tell me that that mean or standard deviation is from a sample. In fact, they tell me that it's generally accepted. I keep hitting random sh's. They tell me that it is generally accepted that that is the mean and standard deviation. So this is real deal mu and real deal standard deviation. And then we keep going. Now we get our information about our sample. The psychologist interviewed a random sample of 35 students, there's my n, and found that the sample mean for these students was 6.2. So this mean here is an x bar. So the next question says to fill in the blanks. Now, a very common mistake, if I had a blank here, a lot of students would want to put 6.2 there because that was our x bar. But remember, this distribution describes every single possible sample mean. So we need to leave that x bar there. And then we can see it says fill in the blanks to describe the distribution of the sample mean amount for our sample of 35 students. So like I said, x bar, we will never replace this with 6.2. And then we can go ahead and say, okay, if we have non-normal to begin with, the best we get is approximate normality from the central limit theorem. And then we're going to look at our formula sheet. So on the formula sheet, you can see here the mean and standard deviation for a sample mean are on the formula sheet. Don't grab the original mean and standard deviation because while the original mean is correct, the original standard deviation needs to be divided by the square root of n. So I'm going to go ahead and grab those two formulas, take them back over to my exam review. The mean of the x bars is the real mean, which we already know is 7.1. So I can go ahead and throw that in here. And the standard deviation of the sample means is the original standard deviation divided by the square root of n. So this is 1.75 divided by the square root of 35. So I'll have to bust out my calculator. 1.75 divided by the square root of 35. 2.958. Right? Right. Okay, cool. And now the next question, like I said, the always part B, it says find the probability. Now, as soon as we see that, we know we're using our normal curve because we have approximate normality, right? That's what lets us know we're doing that. Centered at 7.1, and we keep reading that the average in our sample is more than 8. So now we have an x bar to use with this distribution. So more than 8. 8 is over here, more than is this, and we're doing normal CDF. 8, crap ton of 9s, and then that mean and standard deviation from part A. So do not grab this standard deviation up here. As soon as you make this standard deviation, cross that thing out. And then you just type that into your calculator. Riveting video to watch me type into my calculator, I know. Boom, 0.0012. Cool. very unlikely that the average would get more than 8 hours. And then part 2 or part 3 is that optional part C. I said might not be on the test, the possible one. This one says, what is the 80th percentile for the mean amount that a sample would get? So now we're going, okay, I want a percentile. I need the mean amount of sleep. This is an inverse question, right? I could draw my picture. We're still dealing with our normal, 7.1. 80% means that 80% get less sleep than this value. And we're looking for that. So we're doing inverse norm, 0.8, again using the same mean and standard deviation from before. So these questions, these sampling distribution questions, the hard part is doing this, figuring out which distribution we're in. And then once you do that, it's just right back to exam 2, normal CDF, possibly inverse norm. So I'll go ahead and do that one too. And the most common mistake is just not using the adjusted standard deviation because we're dealing, with a, I left out a comma. Because we're dealing with a, oops, that was not where the comma needed to go. God, I cannot think and type at the same time. We're dealing with a sample mean and not just a value from the distribution to begin with. 7 point, the giant yellow marker. I totally forgot. 7.348 or 7.3490. And then, of course, inverse questions. You always got to put down our units, hours. All right, so that's the example from part 7. Part 6 is the one below. As we read through part 6, we see, suppose it is known that 34% of students wear contact lenses. They just gave me a P. If I wanted to dive a little deeper, wearing contact lenses is our X, our variable, which is categorical. It's either a yes or a no. And this is real deal P because it says known, right? There's nothing here to suggest this is from a sample. So this is real deal P. And then we have a random sample of 100 SDSU students is selected. So we have an N and a P. And then it says fill out the blanks correctly to describe the distribution of the sample proportion who wear contact lenses. So again, on the test, these could be blanks. They probably will be. And you're going to want to put, okay, what we're talking about, sample proportion, and then your only option for sample proportions is approximate normality. And then again, this is on your formula sheet, just like it was for the means, except for it's even more obvious. It even says exactly what the title of that section was, find the distribution of a sample proportion. So you're going to grab your mean and your standard deviation calculations from here. So again, I'll rewrite them. The mean of P hat is real P, which is 35%. Notice how these means are very easy. The standard deviations are where we have to do some calculations. The standard deviation of P hat is PQ divided by N. So the square root of 0.35 times 0.65 all over 100, which of course I got to bust out a calculator for. The most common mistake on these is that students will use parentheses and they will close them off too early. Boom, 0.0477. All right, and then as I said, there's your part A, right? Your part B is going to be to use that to find a probability. What is the probability? So we know, okay, probabilities for normals are all about areas under the curve. So let me draw my normal curve centered at 0.35. And then we see we're looking for between 25 and 30%. So 0.25 to 0.3. Now here's where you do not want to get distracted by that inverse norm. I know you're given percentages here, but these percentages are cutoffs and we want a probability. So we're still looking for an area under the curve. And remember, part A, describe the distribution. Part B, normal CDF. Lower, upper, mean, standard deviation. And I'll be lazy and not calculate this one. But that pretty much sums up the free response versions you're going to see from part 6 and part 7. Now I do have one more question which sort of shows you the multiple choice questions. We can see here a group of researchers wanted to estimate the mean birth weight. Suppose they decide to increase the sample size from 200 to 500. I want you to take a moment, see if you can pause the video here, and see if you can get the right answer. All right, so coming back, we're talking about means. We know we're increasing our sample size. So n went from 200, and now it is going to 500. How will this affect the distribution of a sample mean? Well, remember, you can go to your formula sheet if you need to. Distribution of a sample mean is all about these things, right? So we can go back to these two calculations or these two formulas and put them there to help us out with this problem. So we could remember, okay, the mean of the x bars is the real mean. Standard deviation of the x bars is the real standard deviation divided by the square root of n. So we can see n is only in one of these two values. So the mean is not going to change. It's going to stay exactly where it was. So we can get rid of a and b because they don't say that the mean will stay the same. We can also see that n is here in the denominator of standard deviation. So it's definitely going to change. And if n gets bigger, the standard deviation, since we're dividing by the square root of n, should get smaller. So your correct answer was answer choice D. So there's usually something somehow related to this idea that as we take a larger sample, we see less variability in our sampling distribution. I'll pause the video or stop the video here. It's already gotten long as hell. So I'm going to break this up and I'll do the rest of these sections as their own videos. And you can decide. You can just go through the keys that are up on Blackboard. You can watch me walk you through and remind you of what's going to be on the test. Up to you.